So in this recording, we're going to look at configuring an ACL. Now, in the last module, you actually looked at the theory behind an ACL, and you could see how that actually worked within a network or when it's configured on a device. In this one, we're actually going to be creating the access list. So we're going to be looking at standard and extended. We're going to be looking at named and numbered ACLs. So if you remember from your previous section, your standard ACL filters based on source address only, whereas your extended ACL does source and destination, and it can do port numbers as well. When you're configuring an ACL, you have a few suggested things. Now, to kind of lump all this together in this area that you see right here, one of the things that you can do to configure a device is to go right into the device and start configuring. The other thing you could do would be to configure it in a text editor. If you're configuring a text editor, you're writing out all the commands in your text editor. It gives you the opportunity to make sure everything is correct, to kind of double check it. And then you just copy and paste that into your router. Because as you remember from your previous class, or this class as well, when you type things into a Cisco router, the changes take effect immediately. So if you make a mistake, you could be stopping traffic flow or permitting traffic flow that you don't want to be permitting or denying at that particular time. So typing it into a text editor definitely helps. It also helps if you have a long list of ACLs, and that's typically the case in most organizations, is that you could have page after page of ACLs. So if you're not careful, it would be easy to mess one of those up, and you're doing that in a live device, and you really kind of have to scramble around a little bit to kind of make the adjustments that you need with your ACL. But if you have that in a text editor, it does make it a lot easier to copy and paste that in. You can also use remark statements. So if you'll remember from when we've used remark statements before, remark statements don't affect the functionality of an ACL. They don't affect the functionality of a router, but what they do help with is giving you a little bit of information about the ACL. For example, if you do have page after page, if you have 3 pages of ACLs on a particular device, you can look at the remark statements and it will tell you what that particular ACL does. Kind of like the description on an interface would be a good example of how a remark statement would work. So with your numbered standard ACLs, we're looking at IP version 4. This is the particular syntax. So you're in your global config, so you've done your config T and your access list and the number. The number range that you're going to use would be the 1 to 99. And then you're going to permit or deny the traffic flow. You can include a remark statement, and you're going to include the source address with the wildcard. And then you have log on the end. The log is an optional. You see it right here, it's optional. And what that would do is actually log all the entries of the matched packets within your ACL. So that would be how you would configure a numbered ACL. If you're doing a named ACL, this would be your syntax. A named ACL provides the same function as a standard ACL, but instead of using a number, you're providing a name. So IP access list standard and its name. Okay. Now, just like all your other commands, if you want to remove a command, you can type the word no in front of that, and that would remove a name standard ACL. Notice your prompt changes to this when you're configuring a standard ACL. So when you actually write out your ACL statements, then you have to apply those, because you can have a great ACL, but if you don't apply it to an interface, then it won't do you any good. So you'll actually group all your statements together by using the IP access group command, and then the access list number or name, and then in or out. So in this particular scenario that we have here, assume only PC1 is allowed out to the internet. So we're using PC1 here. Only that one is applied out to the internet. So they're using a standard ACL. Now, they're applying that outbound on the S010 interface. With your standard ACLs, you want to apply as close to the destination as possible because you're only filtering based on your source address. So if you were to apply it going inbound on this G000, it would block access to this network and this network. So that's why it's close to the destination as possible. So the commands that they've used are access list 10, because that's in between the 1 and 99. They used a remark statement. ACE permits only host 192.168.10.10 to the internet. Okay, access list 10. Okay, that was just the remark statement. So here's your actual command. Access list 10, permit host 192.168.10.10. Now you could have also typed access list 10, permit 192.168.10.10 and then your wildcard mask of 0.0.0.0, because remember the zeros in your wildcard mask would tell it to check every single bit. So that would be the other way you could do it. So if you look at your access list, you will see it entered here. Okay. Now, notice it says permit 192.168.10.10, and that's access list 10. In your next one, they wanted to create another network policy that states that the host in LAN 2 should also be permitted to the internet. So you would write a second access list statement. So access list 10, the remark on this is ACE permits all hosts in LAN 2. Access list 10, permit 192.168.20.0, and notice your wildcard mask, because it doesn't matter what the IP address is as long as it's in the network. So that's why you have 192.168.20.0 and then 0.0.0.255. So what you're actually doing with the 0.0.0 is you're matching what's here. The 255, which is all ones, indicate that you don't care what's in the last octet. So if you look at your access list, you have access list 10 and 20. Then you go into interface serial 010, which was this one, and you apply it out. If you do a show run, you'll see, and they did a pipeline section, and just looking at just the access list, you will see those listed. If you do a show IP interface serial 010, and they've done the pipeline, include access list, you'll see the ACL there too. Now again, that pipeline is used to just pick out that specific information. You can do a show IP interface and see that as well. You won't see it on the brief command, but on the general show IP interface, you will see that. An example of a named standard IPv4 ACL would be right here. So what they've done is gone in and removed the numbered, so they just did no access list 10, and that just removes the whole thing. So they wanted to add the named IP access list standard permit access. They've added a remark statement about permitting host 192.168.10.10, and the command is permit host 192.168.10.10, and let's see, we have another remark statement, permits 192.168.10.10, and the host command. Then we've added another remark, ACE permits all hosts in LAN 2, permit 192.168.20.0, 0.0.0.255. So that's just like the one we had earlier, but this is just a named ACL, and they've applied it the same way. If you're having trouble understanding whether to apply in or out, think about the router and look at the traffic flow. So they're trying to prevent this device from getting over here to the internet. Well, that traffic flow is exiting the router. So that's why you want it applied out. You can use any of your show commands. You can look at each of these. So I would encourage you to kind of do that and make sure you run through the syntax checker, because ACLs are extremely important in your understanding of those. You do have a couple of packet tracers where you get to practice that as well. Now, it's also important to understand how to modify an ACL. So one of those is by using your text editor, as I mentioned earlier. You can also use sequence number. If you're using a text editor, then you can copy and paste the output into your text editor, make your changes, and copy and paste it back. So that's what they're referring to here on correcting that error. So once you have changed that, what you can do is go in and remove what was there before. So you'll want to do a no access list 1, remove that statement before you can apply the new one. If you're using sequence numbers in an ACL, then you can use this method also. So ACLs, when they're applied, they automatically create numbers. The sequence numbers are automatically assigned when the access control list entry is made. So you see here for ACL 1, you have a sequence number of 10 and 20. So this is with a standard ACL. It's with a named ACL. And they go in IP access list standard 1 and just say no 10. So instead of deleting the entire access list, they just delete this entry up here. And then they retype that. So 10 deny host 192.168.10.10, and you will see the change made here. Okay, and they've modified it using another entry here. So next, let's look at the show access list command. The show access list command actually has a counter here which tells you how many matches have been made. If you want to clear that out, this is your command to do that. So you clear access list counters and then name the ACL that you want to clear out. Again, you have an syntax checker and you have a packet tracer here. So I would highly recommend doing those, and that will help with your understanding. One other type of standard ACL is an ACL securing your VTY connection, which would be your telnet session. So that is a standard ACL. That one's done a little bit different than the other ACLs. Now you go in and actually write it the same, but instead of access group, when you apply it to an interface, you apply it access class, and you also apply it at the VTY line. So in this particular scenario here, they're going to use a named standard ACL. And this is going to be created for PC1. So they've gone in and created the usernames, IP access list standard, admin host. This ACL secures incoming VTY lines. So they're going to permit 192.168.10.10, deny any, which would mean deny any other devices from being able to telnet in. So it's only allowing telnet access for PC1 only. So when you go in to your line VTY 0/4 login local transport input telnet, so this is just setting up your telnet, access class and the name in, the name of your ACL. So again, you're not going to figure out whether you apply in or outbound to a particular interface. A lot of people make that mistake of trying to figure out what interface to apply it to. It will not work. You have to apply it to your VTY line. And it's always in, okay? It never goes out on VTY line because you're trying to connect into that telnet session. Now here they're using SSH, but again, it's in, access class in. Now, when you're verifying that, what would happen is you would try to telnet in from that particular device or SSH in that device, so the 10.10 that's permitted would be allowed. The other devices would not. They would receive an error message about that connection being refused. So keep in mind that that's just a little bit different when you're configuring a VTY line. Again, I've seen a lot of people make that mistake. On a final exam, for example, or midterm exam, they'll start trying to apply it to an interface when it needs to be applied to your VTY line. So that's your standard ACLs. So again, make sure you do your exercises within the chapter, and that will help. This is one of those concepts that can seem very abstract to you unless you have a good understanding of your wildcard mask and an understanding of how to apply your ACLs inbound or outbound. If you ever get confused on that, again, look at your traffic flow to see if you're trying to catch traffic as it's coming inbound on the router or outbound. Or as I often tell students, kind of stand in the router. Think of your router. Is the traffic coming towards you or away from you to determine whether it's inbound or outbound?